Hey guys, it's Miss Johnson, and I am here to bring you our notes for Unit 1 Notes 3 on slope-intercept and point slope form. So that's our learning target for today. I can graph equations in a slope-intercept and point slope form. So go ahead and find your notes sheet if you haven't taken it out already. You're also going to need something to write with and possibly your calculator. So up at the top, we have some terms that we need to identify here. Slope-intercept form of an equation is the most common form of an equation that we know. Um, it's the y equals mx plus b, probably a form that you're very familiar with and worked a lot with last year. Recall that m is the slope, the variable for slope, and b is the variable for y-intercept. So slope is like the rate of change, and that brings us to our next thing. We also call slope rise over run. We also call it change in y over change in x. Y2 minus y1 over x2 minus x1. Change in x over change, or change in y over change in x. However you want to think of that, that is slope. So the change in the y's divided by the changes in the x. The y-intercept is the point where the graph crosses the y-axis. It's also known as the y-value where x is equal to 0, because if it's crossing the y-axis, x is 0 at that point. Okay, and then slope-intercept form is most commonly used when we want to graph linear equations. So when y is alone, it's in slope-intercept form, and that's when we can most easily graph an equation. So let's just practice writing some equations in slope-intercept form. So up at the top, number one, if I have a slope of -2 and a y-intercept of 2, and I want to write my slope-intercept form equation, remember that that is y equals mx plus b. I'm simply going to take the m, plug it in there, take the b, plug it in there. So my equation for this situation looks like y equals -2x plus 2. So m goes in, the slope goes in where the m variable is, and the y-intercept goes in where the b variable is. In number 2, now I have an m of 4/3, and I have a b value of -4, or in other words, slope of 4/3, b value of -4. So y is equal to 4/3 times x minus 4. Now you can certainly write that as plus -4, but you won't see it that way if this were something like a multiple choice test like the ACT. You'd see it with -4 behind. Now let's talk about how we would write an equation from a graph. So the two things that we need to know are the m, what's the m, and what's the b. The b is pretty easy to find usually. The b is where it crosses the y-axis on the graph. So when I'm on the y-axis, the graph crosses it down at -2. So I know that b is equal to -2. Now the slope, the m, is a little bit more tricky. I need to count the rise and I need to count the run. So how much does the graph go up or down versus how much does the graph move to the right? So in this case, I will use the 2 points that they gave me, and I'm going to count up. I go up 1, 2, 3, 4, 5, 6. So that's a rise of +6. And then to the right, I go 1, 2, 3, 4. That's a run of +4. So that means my slope is 6/4, rise over run, which is also the same thing as 3/2 if I reduce that fraction. So here's my b value. Here's my slope. My equation looks like this. Y equals 3/2 x minus 2. By the way, notice that you have a positive slope here, and your line has a positive increasing line to it, direction. It's going, as you read the graph, which we read them from left to right like we read a book, as you read the graph increases or goes up. That's a positive slope. So your slope should be a positive number there. So now when I look at number 4, again, I need those two things. What's the m, what's the b? B is easy to find. Where does it cross the y-axis? In this case, it's +1. Then slope, I need to count the rise and the run. This time, my line is decreasing. So I know that my slope is going to be negative because my line is going down as I read it from left to right. So I'm going to count from the 2 points that they marked for me. I go down 1, 2, 3, 4. So that's a -4 rise. And over 1, 2, 3, 4, 5, 6, a +6 run. So my slope is -4/6, or in other words, -2/3. So negative 2/3 is my slope there, which makes sense because it's a negative sloping line. It needs to have a negative value for its slope. So here my equation looks like y equals negative 2/3 x plus 1. All right, let's take a look at number 5. Now we're going to graph the line. When I graph a line that's in slope-intercept form, I always like to start with the y-intercept, which is here up here at positive 4. Okay, because that's a good just place starting point. And then once I get the y-intercept on there, then I need to count the slope. Remember that slope is rise over run. So this negative 3 is really negative 3 over 1, which means I'm going to go down 1, 2, 3, and over 1. Down 1, 2, 3, over 1, down 1, 2, 3, over 1. I always like to make enough points so that I can get myself kind of a nice straight line here. Connect your points with a line. Don't forget to put the arrows on. I always like to span the entire coordinate plane. That comes into play more so when we start graphing inequalities later in this unit, but spanning the entire coordinate plane is really important when you draw your line in. So then in number 6, y equals 2x minus 2, I start with my y-intercept, which pay attention to that negative in front. It's a negative 2, so I'm down 2. And then my slope is positive 2, so that's up 2 over 1, up 2 over 1, and so on. And then draw yourself a nice straight line. All right. So let's flip over to the back of your notes and we'll move into point slope form. So slope intercept form, probably the most common form of an equation that we'll see, the one that's most useful. When I get that y by itself, it's really telling as to what the equation or function or graph is going to look like. So, but sometimes slope intercept form isn't always automatic. Sometimes we need to use another form to get there. And one of those other forms is called point slope form. So here's what point slope form looks like. Y minus y1 equals m times the quantity of x minus x1. Okay, so now the y and x are still the variables. M is still your slope, so that didn't change. This is just your variable. This is another variable. But then the other thing that we use in point slope form is an actual point, which is why it's called point slope form, because it has a point in it. It has a point and it has a slope. So the point, the y value goes on the left side with the y, and the x value goes in the parentheses with the x. So this is going to be some point on the graph that you're given or that you can see on the graph, and this is going to be your slope. Those are the two things that are in point slope form, which makes sense to its name, point and slope. When do we use this? We use this when we're given different types of information. So we use this to write linear equation when we're given a point and a slope, or when we're given 2 points. Okay, so sometimes we don't always have the y-intercept and we can't go straight to slope-intercept form. So that's why we start with point slope form instead. So let's take a look at number 7, and let's just practice writing what this looks like. If it helps you, go ahead and just label across the top of what these things are, where they go in the equation. So this is your m value. M is equal to -6. And then in a point, we always know that this is the x value goes first and the y value goes second. So that's going to be my x1, that's going to be my y1. And now let's take a look at what that would look like in the equation. So in the equation, I have y minus the y1 value, which is 2, is equal to the slope, -6, times x minus the x1 value, which is 9. Okay. So there's my point slope form of the equation. Now I could keep going and take this further into slope intercept form, which we'll do in a minute, but just know that that's what point slope form looks like. It has a point in there, the x value, the y value, and it has a slope. So let's look at number 8. In number 8, this is my m, which you're told. This is your x1, this is your y1. So now let's put that into the equation. I have y minus -3, because that's a -3, so it's minus the -3, is equal to 2 times the quantity of x minus the -2. Now, you would not see it written this way if this were an ACT or an MCA test. You would see that minus and negative slash together to be positive. Same thing over here. Minus and negative we all know is adding a positive. So y plus 3 is equal to 2 times the quantity x plus 2. All right, let's move on. Let's talk about number 9. So then it says write the equation in point slope form, but now we're only given 2 points. We're not given the slope. So we've got to go back and find the slope first because I can't put it in point slope form without a slope. I have to have a slope. So remember that finding slope looks like this. I want the change in x over the change in y. I'm sorry, hello. Change in y over change in x. I said that backwards. Change in y over change in x. Again, if it helps you, label your points. Here's an x value, here's a y value, here's an x value, here's a y value. Now it doesn't matter if you go first point minus second or second point minus first, as long as you do the same for both the y and the x. Okay, so I'm just going to go second point minus the first point. So I have 4 minus negative 12. And on the bottom, I have 8 minus 4. So that was y value minus y value, x value minus x value. And now let's actually solve that. So 4 minus negative 12, add those together, that's a 16, because minus and negative is adding. 8 minus 4 is 4, 16 divided by 4 is 4. So that's my slope. Now, you have 2 options. You have 2 choices. You have the point slope form for the first point or point slope form for the second point, and it doesn't matter because they're both points on the same line. So you can write it using either option. So if I use the first point, it looks like y minus negative 12 equals 4 times x minus 4. Or in other words, y plus 12 equals 4 times x minus 4. That's one of your choices for the point slope form, okay, using the first point and the slope that we found. Or you could use the second point. If I use the second point, it looks like y minus 4 is equal to 4 times x minus 8. So put that y value in, put that x value in, and put your slope in that you found at the beginning. Okay, so let's talk about number 10. We're given 2 points again. So the only thing I can do with 2 points is find the slope. That's the only thing I can do. So the first thing I'm going to do is find the slope. So I am again going to take my second y value minus my first. So 2 minus negative 7. And then on the bottom, 2 minus negative 4. And when I simplify those, minus negative is adding, 2 plus 7 is 9, minus negative adding, 2 plus 4 is 6. So 9 over 6, but I can reduce that to 3 over 2. So that's my slope there. And then again, you can use either point to write the point slope form. Both of them are true. So I'd have y minus negative 7 is equal to 3 halves times x minus negative 4, which again looks like y plus 7 equaling 3 halves times x plus 4. Some of you will start to recognize that double slash without having to write them both out. So as long as you recognize that you're subtracting a negative and that goes to addition, that's an okay thing to do. The other option would be using the other point. So I'd have y minus 2, which is the y value, is equal to 3 halves times x minus 2, which is the x value. So both options work, both give you a point slope form. All right, so now let's go between the two. So now we want to um, take in number 11 the slope and the point that are given to us, and we want to write them in slope-intercept form. So not point slope form, which is what we just did. We want to go to slope-intercept form. So, but here's the thing. We don't have the y-intercept. We have to find the y-intercept somehow. So I'm going to use point slope form because I'm given a point and a slope. I'm going to put them into point slope form, and then I'm going to go to slope-intercept from there. So when I put them into point slope form, it looks like this. Y minus 3 is equal to negative 3 times x plus 2. Remember that when you're subtracting a negative, it's that plus a positive. Okay, so now I want to go to slope-intercept form. Now pay attention to slope-intercept form. When you look at slope-intercept form, the thing that's by itself is the y. So that's what I'm going to work towards. I want to get y by itself. So what I need to do to get y by itself is first of all distribute this -3. So I have y minus 3 on the left that I haven't touched is equal to -3x minus 6 on the right. Then the only other thing I need to do to get the y by itself is to add 3 to both sides. Y is equal to -3x minus 3. Okay. And then if I take a look at number 12, now I'm just given 2 points. I'm just given 2 points. And the only thing I can do with 2 points is find the slope. So that's where I'm going to start. I'm going to start with finding the slope. I have 17 minus 5 over 2 minus -4. So 17 minus 5 is going to give me 12. 2 minus -4, that's adding, gives me 6. 12 divided by 6 is equal to 2. So that's my slope. Now I can use either one of the points. It does not matter which one you pick, and I'm going to find the y-intercept. So I'll just use the first point. Y minus 5 is equal to 2, the slope that I found, times x plus 4. Because that 4 is negative, so it's going to be minus a negative. So then I distribute the 2. Y minus 5 is equal to 2x plus 8. And I add the 5 to both sides, and I get y is equal to 2x plus 13. So that is my slope-intercept form now that y is by itself, and I've got my equation. All right, thanks for tuning in, and don't forget to come check off your notes sheet so that you can get your practice sheet and keep moving on in the course. Have a great day.